Thanks, Ali. Hi, everybody. Welcome. I should introduce myself. My name is Mark Heslop. I'm the International Maths Subject Partner here at Pearson. And it's basically my job to support you with any queries about the specification, deliver a lot of the training, and makes the case here, give you a lot of the insights from this summer's examinations. So, quick agenda for you. And if you see me looking left here, it's because I have this on another screen. So, we've got a few notices especially about modular. We're going to look at some foundation tier insights. Now, I'm aware the majority of entries are higher tier, so we're going to concentrate on the higher tier insights. We're going to look at some tiering guidance, because I know that's quite an issue for centres that they get a lot of pressure to enter all their students for the higher tier. We've got some resources for you, and basically that'll take us to the full hour. So just in case you haven't seen it already, we've got a new modular version of the specification out, exactly the same content as the linear specification. We have no plans to change our specification. We like to get our content right at the start of the course and keep it constant throughout. It's the stability that teachers like. Having said that, we have introduced a modular version, which has the same content as linear, but defined content per paper. Now, I'm getting a lot of questions about how centres can make entries. So I thought I'd just kind of summarize the questions that I'm getting. So I'm actually getting questions from centres saying, if I use the linear papers, can I take them both at the end of the 2 years? But some centres saying for their students, it makes sense to teach in a linear way, not interrupt the course with exams in year 10. Even though I think there's a lot of advantages to the students for doing so, you can enter at the end of the 2 years of both the modular papers in place of the linear papers. I'll come back to why you might want to do that in a second. And there's the original design of the qualification, which was for students to do a summer of year 10 unit and then a summer of year 11 unit. And I do have some centres saying, well, my students might not be mature enough at the end of year 10, so can I enter in the autumn term of year 11 for the first unit and the summer of year 11 or the second unit? And that's absolutely fine. The other advantage to doing that modular, is actually resits. And this applies especially if you have students who've done the linear course, but taken the modular papers. So if you have students in the sixth form that need to increase their grade, maybe it's an entry requirement for university, maybe they've got a 4 and need to push it to a 5. If you've done the modular course, you can retake papers one at a time. Whereas if they've been entered for the linear papers, they would have to take both in the same series. There is another advantage. So just to come back to that tiering pressure from parents to enter everyone for the higher tier, because I see in the exam statistics quite a lot of students, or more students than I would expect, getting a grade 3 on the higher tier. It's quite likely that those are students that would have been able to get a better grade if they've been entered for the foundation tier. But just to give you an introduction to the options you've got on that one, you could enter them in for all your students for the higher tier unit in the summer of year 10. If you've got some students who really struggled on this paper, you could see what it's like for them on the foundation tier in the autumn of year 11. Now, you can't cash in a foundation and a higher tier paper to get a grade. You have to have done either both the foundation or both the higher papers to get a grade. So once they've done the foundation tier paper, it's then a case of deciding whether to finish off the second foundation unit or the second higher unit. The alternative is if you actually have dedicated foundation tier classes. So if you, at the end of year 10, have some foundation students who've done really, really well on that unit 1, you could boost them up with the extra material and try them on higher unit 1 in the autumn term, and then decide whether to finish off the foundation tier or the higher tier in the summer, whichever's best for them. So let's crack on with some insights of this summer. And like I say, please do say hello in the chat as to where you're from. Okay, so I've got here, there's a lot of statistics on here. You'll get all these statistics afterwards, but this is the performance of the exam questions broken down. And what I've done is I've highlighted the top 10 questions at each grade in terms of performance and the lowest performing questions at each grade. Now, we'd expect those harder questions at the end of the paper, students to struggle on them. They're designed to test them. What I am seeing on the foundations here across both papers is students not picking up as many marks as they should do at the start of the paper. This seems slightly different to last year as well. We'd expect the greens to be concentrated in the first third of the paper. And it may well be that it's worthwhile just making sure that the students have had enough practice on those basic questions where they can pick up some very easy marks. And I know what it's like with foundation tier students. We do just forget things. So it may well be that, if you've got entries coming up in October and November for maths, just making sure that students are maybe taking the first third of a paper home for homework and just having a go. These are often questions they don't necessarily need help on from their teachers. They just need to engage with it to just realize, oh, I've forgotten what that was. I'll just go and look it up. Just to give you the contrast with the higher tier, this is what the higher tier paper looks like, where we can definitely see those best performing questions are at the start of the paper. So if you're foundation tier students, please don't underestimate not how much support they need on that first part of the paper, but just that they might need a bit more practice of it to revise a few things. And that comes through strongly in some of the insights I'm going to show you. Now, what I'd like to say is I'd like to keep this session focused. So I'd like the bit to be something on every slide where I'm showing you a question, something that you can take away and do something within your classroom. Please do judge me on that in your feedback at the end, whether you think I've achieved that one. But I'm trying to give these, there's a lot of things that are for interest in the exam statistics. I could talk for hours about them, literally out. What I'm trying to give you here is things that you can take away to your classroom that you can do something with. So let's have a look at question 6. So regular octagon, number of lines of symmetry. On the shape, mark with letter R a right angle, mark an obtuse angle, and find by measuring the size of an angle of the angle marked X. So here is the exam statistics by question part by grade. You can see the red ones are in the bottom 10 performing questions. Now, I haven't got too much of an issue with this one. Lines of symmetry, especially for even-sided shapes, can be quite tricky. I'm slightly more surprised by D, even though it's not necessarily in the top 10 or bottom 10 questions. So here we go. Across all students, only 53% could measure an angle. Now, my question is, do they have the right equipment? So the examiners do feedback that they get students writing on their papers. I couldn't do this question, whether it's measuring a line, measure an angle, because I didn't have a protractor or a ruler in the exam. So does your exams officer, at the start of the examination, check for the equipment the students have got? And I know if we ask students, is there anyone who's missing anything in an exam hall? They're going to feel very self-conscious about putting their hand up. So I know that I can, with a hall of 180 students at the start, before the start of an exam, before I hand over to the exam team, right, ladies and gentlemen, put your equipment out on the desk, and I can do a quick visual check in about a minute of 180 students. And at that point, we can just help students. We don't want to unsettle them. We want to support them. Help students who haven't got the right equipment in an examination, and then hand over to the examining team for the delivery of the exam. So that's, I think, equipment. And I would say for students taking the regional papers, shape and space for foundations here, and shape and space with algebra for higher tier students is an issue that just need that bit more practice. Okay, let's move on. Okay, so we've got here simplification, nth term, and show clear algebraic working for solving. And it's part C I just wanted to draw your attention to. So I'm really concentrating here in these slides on topics that performed in an unexpected way. It's fine that students find the questions at the end of the paper difficult, the start easy, but I'm just trying to pick out for you here topics that I would have expected students of these grades to perform better on. And I think question C is actually a key example of this. So nth term of the sequence, find the first and fifth term of the sequence. Now, I could, and I will do for other questions, I will pull you out alternatives just to demonstrate students do better on this that we would all classically view as being a harder question. But I think it's worthwhile for your foundation tier students, just checking your assumptions of what you think they might just need regular practice on. And I would suggest nth term in here is probably an interesting one for these students. I mean, I would say that a lot of students may struggle with this, part B. But if we look at part B, it performs better than just a straight substitution. And that's the bit I found interesting. There's the mark scheme. I'm not going to go through the mark schemes in full detail. They're mainly here so that when you get the slides, you can actually see the question and the mark scheme together. Okay, so that's paper 1. On to paper 2 of foundations here. So write the numbers in order of size. Write these decimals in order of size. Start with the smallest decimal. Write in figure the number 5084, and then write down the value of 3 in 1324. Okay. That was an interesting one. Okay, students did struggle a little bit on part B, but it's actually more, and there are misconceptions around that we understand. Reading this one as 0.37, 0.13, 0.7, and saying that 0.7 is smaller than 0.37 is the misconception we see. But it's actually this one that I found really interesting. And I've got a comparison for you. So here is an alternative question. Barsha buys some nails and some bolts. Each box of nails costs this, bolts cost this. Barsha buys 5 boxes of nails, 4 packs of bolts, and pays with a £50 note. How much change should he should work out how much change he should get? Here's the exam statistics. Okay, so here is that question 8, where an average, which really I think is a real, I think we should be really proud that students on average scored 92% on this question. But we compare that to part D, only 57% of students write down, this is question 1, write down the value of 3 in the number 1324. This is what I mean. Students just need, obviously they're getting a lot of practice at what we call the harder questions on the paper, just need a bit more of a refresh on the easy ones. I found this really surprising. I had to go back and check the statistics that students scored better on this complex question than they did on a place value. And in part B, the examiner said, in part B, some students confuse themselves when ordering decimals between the decimal numbers 0.13 and 0.17, which we understand. But in part D, place value caused problems for some students, hundredths being the most popular wrong answer. I think we just need to be setting students these kind of first part of the paper as homework, checking them in class, and just doing a very quick intervention with them. Okay, so paper 2 again. So we've got find the value of 3.4 squared, find a cube root, write this as a single power, and then write 1 set of brackets in each calculations to make the answers correct. Now, what I am going to be drawing your attention to is part B here and part D. And I'm going to pull up the statistics. So part A was actually one of the best answered parts on the paper. Whereas part B here, 57% could find a cube root of this number using their calculator. DI, 87% of students effectively got the mark on this one. So I'm just doing that comparison again. Part C wasn't entirely surprising. I think that's a little bit challenging for students, or can be challenging for students, but I am surprised about part B. Do your students know how to find a cube root on their calculator? Do they have a calculator that can find a cube root? Worthwhile checking, and again, just engaging with that first part of the paper. So to summarize for foundations here, and I have brought in some other comments from the examiners here. So plenty of practice for homework on the first third of the paper. Check their calculator use. Ensure they've got the correct equipment for the exam, including the protractor, compass and ruler. And then just a few comments from the examiners here. So be aware that the answer line takes precedence, and they should always write the correct answer there as a key point from the examiner. So if they've got 2 methods, we're going to mark the one that leads to the answer line. And then for higher tier. So again, we started to see the statistics of the higher tier, and we can see for the paper 1 that nice spread of questions at the start. I'm just going to have a sip of a cup of tea. that students were picking up good marks on. Question 2 was a little bit different. I don't think, I'll show you the statistic. I don't think there was a major problem here. I think it was partly caused by a couple of questions that I'm going to actually look at on paper 2. So there's a lot of subparts on paper 2, more than there were on paper 1. Generally speaking, I think students are picking up the majority of marks on the start of the paper. It's foundation tier students that need to be concentrating on those. So let's dive in and have a look at some of the paper 1 questions. Okay. Complex question. So diagram shows a solid wooden cylinder. The volume of the cylinder has a radius of 8 and a height of h. The volume of the cylinder is 1208 cubic centimeters. Work at the value of h. And part A was one of the highest performing question parts on the paper. Part B, the density of the wood is 1.25 grams per cubic centimeter, and work out the mass of the cylinder. Give your answer, and here's the key point, in kilograms. So, just to refresh that point, I am seeing students struggling with shape and space questions where algebra is embedded in. And if you're going to be practicing, especially if you're making entries for the November-October series, when you're practicing questions with students, make sure that you're giving them good experience of algebra for your higher tier students embedded in shape and space questions. So for your foundation tier students, basic shape and space questions. So the examiners say for part A, many of the students able to gain 2 marks as they set up an equation for the volume of the cylinder and solve h. Of those that didn't, many were unable to correctly rearrange, and others had an incorrect formula for volume. E.g., the volume of a cone was often seen, which is often disappointing considering the formula sheet given on page 2 of the paper. And what I do see, and I saw this last year, is students using an incorrect or wrong formula or something that is in the inside front cover of the formula sheet. So last year, students were working in one of the papers with the volume of a sphere, and they were using the wrong power. They were using r squared instead of r cubed. My question for you is, how often do you refresh the students by saying, have you looked at the formula sheet? Okay, these are the formulas that are there. Checking during an exam. What formula have we been given? There's absolutely nothing wrong before you hand over to the exam team. If you're doing that equipment check amongst the rows, and say, the first thing I'd like you to do, ladies and gentlemen, is just when you put your name on the paper, check the formula sheet in the front. So just refresh what information is given to you, and then hand over to the exam team for that delivery of the exam. But I think it's crucial that students be aware of the formula that are there. The examiners did also say that some students failed to convert their to the correct units at the end. Some students did recall an incorrect formula for density or had the correct formula but couldn't rearrange it. So that's one that's worthwhile just refreshing your students. Just getting your students to just check that they've answered the question in the units that are required is key. Okay. Let's go back one. Sorry, gone too far. So again, area of a trapezium. So again, we're talking about here shape and space algebra. And it does seem to be discriminating between, especially when I'm looking at the statistics. We can see for grades 9 to 7, those top 10 performing questions on the paper. And if you're looking for an indicator between kind of mid-grades and high grade, often that shape and space and algebra is a good indicator for international students. So you can see where it suddenly starts to drop off and tails away for those grade 6 students. The examiners did say right at the end that there was some confusion with finding the perimeter. So the students had actually done the majority of the question correct, but then failed to actually calculate the perimeter. So it's just a case of just reminding your students to check. And I have got some advice on this later on about where to check and how to get your students to check effectively in a paper. But I think it's important that we just make sure we're underlining some keywords, for instance, that we're working out, perhaps say the perimeter. All right. So I've got 2 questions for you here, and this is going to give me a chance to have a sip of my cup of tea, which I've got to my right-hand side here. So here are so solve the simultaneous equations. 4x plus 3y equals 9.6, 6x plus 5y equals 16.8, show clear algebraic working, and then here are the number of goals scored by a hockey team in its 11th game of the season. Work out the interquartile range of the goals. So this was actually a question 12 was a 4-marker. Question 10 was a 2-marker. Proportionally, which do you think the students found harder as a proportion of the overall marks? Was it simultaneous equations, or was it finding the interquartile range of a number of goals? I'm going to have a sip of my cup of tea. Please just put in 10 or 12, whichever you think the students found hardest. Drop it into the chat with me. Let's see who's going to be first. Hopefully you've been in, and this is one of the checks to find that we've got the chat on there. Let's see if anyone's going to put anything into the chat. Who's going to be bold enough? So which one did the student find hardest? Question 12, the simultaneous equation, or question 10? Ooh, I don't think anyone's going to be bold enough this morning. So I'll give you the answer. So question 10, statistical measures. Students scored on average 69% of those 2 marks. And yet, here's the interesting bit, the simultaneous equations, linear equations, 4-marker, students scored on average 87% of those marks. So algebra in itself for international students, very strong, with the exception of algebra in shape and space. Okay, another topic to focus on is some of those ones that we might assume that they just know, but actually they just need to refresh their knowledge. I'm going to flip over to show you the mark scheme. So I'm going to remove this question 12. So here's the mark scheme, 2 and 7 identified correctly, and then 1 mark for working out the interquartile range. And the examiners say that they're perfectly aware of there's different methods for calculating quartiles. If you ever use the statistical package R, I think there's something like 11 methods of calculating quartiles. The 2 main methods that we see at this level are using n/4 and n+1/4. And the examiners deliberately design questions at this level where it doesn't actually matter which method you use, they will arrive at the same values. So that's why the examiners don't give more elaboration within those mark schemes. We're more interested in the concept of interquartile range at this point rather than a specific method. But this is definitely one that higher tier students just need their knowledge refreshing on. I always used to say to the students that, it's okay to not be able to get the marks on the questions you can't do. But it's not okay to lose the marks on questions that you can do where you didn't just show it in the right way, or actually where you just failed to just refresh a little bit of knowledge. And I'm going to go back to just show you something about that previous question as well. This one even says show clear algebraic working. So there's quite a high tariff of entry on this question itself. All right. Shape and space again. Keeps coming up, but I do have some advice for you on this one. Here's the statistics. So out of the 5 marks on this question, out of all students, they gained 48% of the mark. Even your grade 9 students are only getting 3/4 of the mark. So it does say work out the size of the angle OBD and give a reason for each stage of your working. Okay, so the examiners do say a fully correct set of reasons were rarely seen, with students needing all the appropriate circle theorems and angle rules, including the underlined words in the mark scheme. I'm going to show you the mark scheme. So these are for effectively the calculations. These are the reasons. So we need to see, and it's worthwhile practicing these with your students, opposite angles in a cyclic quadrilateral, sum to 180. Classic ones that we get that don't get the marks are where students say things like angles in a triangle are 180. Now that isn't enough to get the mark. It needs to be angles in a triangle sum or add to be 180. And if you're after any guidance on these, if you use Exam Wizard, which I think is a fantastic tool for getting to grips with the specification, we can pull together circle theorems questions and practice them with students and show them the mark scheme to show them the kind of marks wording that they need to show. This is what I mean about it's not okay to lose the marks for things that they can do, and we know what they mean, but we can't award them the mark. The other piece of advice that I've got for you on this one is that students are allowed to work on the diagram. And I've seen, student responses that were very successful where they'd put an angle on here with a calculation and put 1 and then listed reason 1 and the reason here, and then gone down to the next angle, calculation here, label 2, and then a reason underneath. I think that's much easier for students to do, especially if they're working their way around the diagram to get to the angle. Getting them to remember what step or what order they did the stages in is the important part. So 1, 2, 3, 4, put their calculations on, and then list the reasons linked to those. And the examiners do encourage students to actually use the correct notation and to actually use working on the diagram. Good practice is to talk about obtuse angle BOD or reflex angle BOD is the kind of also notation that students benefit from using. For instance, when they're working on this one, they could refer to this as the reflex BOD to just make it clear which angle they're talking about in their notation. So that's what the examiners say. Angles to be identified either by notation or correctly positioned on the diagram. Okay. I'll keep going. On to algebra again. So a curve C has the equation, this polynomial. Curve C has exactly 2 stationary points, point at A and a point at B, such that the coordinate of x coordinate of A is greater than the x coordinate of B. The average mark on this one across all students was 52%. And this differentiation is a great discriminator if you're looking at students between your grade 8 and grade 9 students. And the examiners did say it was pleasing to see that almost 40% of students able to gain full marks for correct coordinates, but some students achieved the coordinates of both point A and point B, and either selected the wrong one or did not select one at all, losing the accuracy mark. Now, when I'm looking across different series, looking at the difficulty of questions relative to each other, I see perhaps that differentiation or the difficulty students face with differentiation is perhaps underestimated by teachers. So I compare questions, and there was one in another presentation I did recently where I had a differentiation, quite a complex proof question, and yet students did better on the proof question than a basic differentiation. If there's a higher tier topic to keep practicing on with your students, it is getting started in differentiation questions. I think I'm seeing evidence that students look at it, think, I can't finish that, and so skip to the next question. But I think if students actually just realize that the differentiation itself is quite straightforward, they're going to pick up at least a couple of marks. They're a relatively straightforward mark. So it's encouraging students to begin differentiation. We do see that once they've started, they can generally finish. But I think it's worthwhile checking your students' knowledge on differentiation. Now, when I was teaching this, I found something interesting. So with sixth form students who maybe hadn't covered differentiation before, differentiating y as a function of x was quite straightforward, and moving on to say x is a function of t, they found more challenging. I actually find it's the other way around for international GCSE students. And I think it might be just a more concrete context to start with displacement as a function of time, velocity as a function of time, relating that to the gradient of the graph, acceleration as a function of time, the differential of the velocity, and then moving on into more generality, differentiating y as a function of x, is perhaps something to explore with your students as to a nicer way for them in context to introduce differentiation. But it's definitely a topic that is worth pushing with your students and spending that little bit more time on as one of the higher level topics. There's the full mark scheme. You can actually see here that we've actually got a couple of full marks for the differentiation and setting it equal to 0. So there's some actually quite straightforward marks that the student can access early on in the question. Okay. Shape and space again, a higher tier students. Okay. This was absolutely a fascinating one when I looked at the statistics. So, describe fully the single transformation that maps shape on A onto shape B. Now, there's an insight here that's come through from previous series, and the examiners say students, where we ask them for a single transformation, they often find them putting in more than one transformation. Now, I don't think that's them misreading the question. I don't think they're, if we've got to say a rotation, they're not doing a translation and then say a reflection to get the rotation, or a rotation about the origin and then a translation. I think it's that, for instance, they don't necessarily know very well how to describe a transformation, especially rotations. They're actually quite good at actually doing the rotations themselves and doing the enlargements themselves. But when it comes to describing one, this is there for them, those are the topics that certainly both the higher tier and the foundation tier students struggle at. The interesting bit was the relative difficulty of these two questions. So here we go. 2A, describe fully the single transformation that maps A onto shape B, was actually more difficult for students than on the grid above, rotate shape A about 180 degrees. I'm going to let you absorb that for a second because I think that is quite fascinating. Students found describing a translation more difficult than actually doing a rotation themselves. And I'm going to fire up the marks because I think there's probably something subtle that teachers miss in here. And it's to do with this. When students are describing, and I checked this with the chair of the examiners, when students are describing a translation, they must put their answer in vector form. That is absolutely key to them getting the mark. So the examiners are very generous with a lot of things on the paper. So the translation, they allow translated, translating, translate. They allow a misspelling of the word translate. For instance, your foundation tier students, if we're asked to name a shape, as long as the intention is clear, even if it's not spelled correctly, the examiners are very generous. But there are certain bars that students should meet. One of them is actually on translation questions using vector notation, please. I think that's probably a key, easy one that we can take back to our classrooms. Okay, set theory. I love set theory questions. I've always enjoyed doing these questions. So this is where we give a set of numbers. Set A is a factor of six, factors of six. Set B is prime numbers, and list members of the set. So my advice here is that students do struggle across papers. I've seen evidence across papers that they are struggling with A prime. And my advice is for you to practice when your students are doing these in class, is to write a worded sentence to explain, so they're just engaging with it and thinking about what A prime means. So a key one here would be not A. So we've got Harpreet states that A and B is an empty set. Harpreet is incorrect. Explain why. And I am seeing evidence that students are far better than teachers may assume they are at answering explain why questions. I think it's too easy to say, oh, they can't do those. They can. There are certain ones where it's the underlying topic that causes the difficulty. And I think that's a good example here. And then we've actually got quite a complicated one at the end. And it's okay for students to struggle with that. It was, an interesting one. And here's the statistics. So for AI, A union B, okay, only 55% of students could do that. For AII, not A, 62% of students could do that. Part B, where we've got that explain, I don't think it was the explain that caused the issue. I think it was an understanding of set notation. And I see this on the home papers, and I see this on the regional papers that I'm talking about today. And I saw it last year as well. Students, higher tier students, need more familiarity with set notation. They really enjoy these questions. I really enjoy these questions. Your maths teachers, you really enjoy these questions. Just a bit more practice. Don't underestimate that they just might need a little bit more help on the notation itself. So here's the mark scheme. Okay. not going to go through the mark scheme in detail, that's for you to see afterwards, but in terms of those explanations, students could write A union or B. A and B is an empty set. So these are the kind of things that I'm talking about in terms of those explanations. Good to do in class. If students need to do it in an examination, then we wouldn't want it to take time away from answering the questions. But it may just be that extra layer of understanding that helps them answer this question. The other one that has come through from previous paper is students don't understand n open brackets, meaning the number of members of that set. Okay, let's have a look at higher tier paper 2, and we've got a cumulative frequency diagram. It's quite a fascinating one. So first of all, we've got to draw the cumulative frequency diagram. Then they've got to use your graph to find an estimate of the interquartile range of times. 20 workers spent more than W hours working from home. Use your graph to find an estimate for the value of W. And then one of the 60 workers is chosen at random. This worker spent H hours working from home. And D, find the probability that H is greater than 5 and less than or equal to 10. Now, there's an interesting thing in here in terms of wording. So we have said in here, and it's worthwhile queuing your students up to this, use your graph to find an estimate for the value of W. We haven't said use your graph in this part here. The students should infer that to mean that they can actually read that value from the table. A lot of students, there was evidence that a lot of students went back to drawing lines on their graph for part D as they did for part C, but that wasn't necessarily the intention of the examiners. So here's the grade statistics, and I think this is really positive. 85% students scored 85% of the marks on drawing the actual cumulative frequency graph. It was a slightly problematic question. It was in the bottom 10 questions for your grade 9 students in terms of estimate for the interquartile range. So there's that interquartile range again for your high tier students. So we're on continuous data this time around. The examiners did say for part A small number of students drew a line of best fit rather than joining the points. And a small minority of students drew an incorrect cumulative frequency graph, usually using interval midpoint or a bar chart using the cumulative frequencies. But I think it's part C in here that's actually key. So use your graph to find an estimate for the value of W. I think what slightly tripped up students in here, 25 workers spent more than W hours. So I think what we're actually after is, if there's 60 students here, we need to read off at 35, not 25. And I think this is a good question to work with your students in class, because above the 35 is the 25 student that we're talking about in the question. But just be a little bit careful with things like finding out interquartile range of cumulative frequency graphs. Nice link here to probability. Like I say, that information can be found from the table. Because we haven't got the keyword, use your graph. The students can use that graph. Okay. Let's go on to the next question. Spotting that theme in here of shape and space and algebra, I'm afraid, ladies and gentlemen. So on here, work out the length of ED. So we have here ED. And finally, so we've got an algebra one, which actually a lot of international students are very good at the algebra, except when it's embedded in within the shape of in shape and space content. So let's have a look at the statistics. Now, to a degree, I'm not entirely surprised that part B performs worse than part A, because it is a more challenging questions. But the examiners do say that students should be encouraged to look at the diagram and decide whether the answer should be bigger or smaller, and consequently whether multiplying or dividing is appropriate. A fair amount of students did do this correctly, but failed to read the question properly and supplied the length of AD rather than ED. So I think, again, a nice question to use as a lesson starter to give that students that variety of the kind of questions that we ask. So a lot of students applied the scale factor here to 10 to work out AD, but neglected to work out ED. And I think part B Again, if you're looking at the results of students, I think part B is a nice grade 8, 9 discriminating question. If you're a bit unsure of the kind of grades that a student might be working towards, I think that's a nice question to help sort them out. There's the full mark scheme. It's a lovely question to go through. Okay. Just going back to some of those basic skills again. Check my time. I'm doing okay for time. I'm going to sip my cup of tea. So 2 questions here. F of x and g of x, given that f g of k equals 2, work out the value of k, and then use algebra to show that 0.306 all recurring is 34 over 111. I'm going to show you those comparative statistics. Here we go. Question 17, on average, students scored 60% of the mark. I think that's something we should celebrate. I think that's a really tough question, and we should celebrate that students can do that. So international students, very good at algebra on its own. Not so good, need more practice in shape and space. Question 18, one of the worst in the bottom 10 questions for your grade 9 students. On average, students scored 56% of the marks. Now, I think that's quite surprising. This should be a run-of-the-mill question, and potentially one we just need to make sure that students have engaged with. But I think there's something more subtle in terms of the actual mark schemes themselves. So I'm going to get rid of that question 17 on the left-hand side, and we're going to have a look at the mark scheme for question 18. Okay. So here we have 2 equations. They don't need to formally solve them simultaneously. It's sufficient to write them above each other with a subtraction side. But the examiners do say, as we're use algebra to show that, there is a slightly higher bar of entry in here. But I think it's totally achievable for students as long as they understand that the stage of this. And these are all run-of-the-mill questions. So M1 for 2 correct algebraic equations involving recurring decimals that, when subtractive, give a whole number. Okay. And in terms of showing the subtraction, I did just want to highlight to you there that the examiners are, as long as the intention is clear, will accept it. But I think the key point is this is definitely a subject where students just need a bit more practice at showing what should be a standard method. There's the second part of the mark scheme for you as well, for that completion of it. And the examiner said this question saw the full range of marks awarded. A significant number of students gained no marks by either failing to use algebra despite the instruction or failing to identify 2 correct algebraic equations to subtract. Of those who did, many lost that second mark by implying the division 998x equals 306 to effectively this without showing the intermediate step. Now, I know we might consider some of this is tough, but I'm just going to remind you a second. I'm going to go back one of this question. Students can do this, and they just need to be a little bit more practice at 18. I think that's fantastic that students can do question 17 very well. Okay. ABCD is a square. Points A and B. Find the equation on the line that passes through B and C. Give your answer in the form AX plus BY plus C. That might have thrown some students where A, B, and C are integers. Average mark on this one, 41%. So the examiner said this is a challenging question, especially for those who felt that they could answer it without reference to a kind of a diagram. Indeed, regarding diagrams, students need to be informed of the convention for labeling polygons. How often do we remind our students of the convention for polygons? I think we perhaps assume they know it. I had further math students, year 13. There was a question about showing whether something was a parallelogram in vectors. And when I got the diagrams back, I realized why so many students had got it wrong. They weren't aware of the convention that we go clockwise around the diagram in terms of the points. They'd done some interesting things. So A, B, C, D. There was A, B, C, D diagonally. So it's just worthwhile refreshing with your students. When was the last time we actually refresh with our students what the convention is for naming polygons or putting the letters on polygons? There is something more fundamental in here, and I'm going to digress on some evidence from another paper in a second. A surprising number of mistakes were made in the beginning with at the beginning with the gradient of AB. Some divided X by Y values, some subtracted X values from Y values, many signs were lost, and there were plenty of numerical errors. Now then, the examiners are asking me to stress that this year, certainly, equations of lines and specifically gradients were an interesting problem for higher tier students. Now, I know you're thinking, actually, we know students struggle with equations of lines. I'm going to show you the scale of that problem on basic ones. They're struggling on basic ones, need just a little bit more revision on them. So here's a question from the main papers. So students have got to draw a line y equals 2, x equals 6, and then draw the line y equals x plus 1. Here's the mark scheme for it. But then I'm going to show you the performance statistics. So 90% of students can draw y equals 2, which I know students generally find challenging. 90% of students can draw x equals 6, but only 2/3 of students can draw y equals x plus 1. Now, the examiners allowed follow through, but in terms of follow through, 81% of those students could actually identify the correct region in relation to their own lines. And identifying regions is very challenging. And I'm using this to demonstrate that students are struggling with actually very basic equations of lines. Here's a second one. Straight line has the equation 5y plus 2x equals 7. Find the gradient of the straight line that is perpendicular to P. There is a lot going on in this question. There's some of the performance statistics in terms of the percentages, but the examiners actually said a couple of key things in here. This seemed like a very straightforward question for the grade at which it was targeted. However, we are now very much of a very strong opinion from the evidence from a great number of students that many do not actually know what the gradient is. We were very surprised that most students seem to think that the gradient is a value with an x or an equation, 2.5x, 5 over 2x. We're commonly seen as the gradient as was the equation with the gradient of 2.5. Please be practicing with your higher tier students gradients on a regular basis over the next year is my advice. Okay, so to summarize what we've got on the higher tier before we go on some resources for you, don't underestimate that some practice is needed on easy topics as homework. So just those ones at the start, such as recurring decimals and quartiles. Please be reminding them of the formula sheet in the paper. Do they have? Sorry, I've just seen that the host has muted me. Is everything all right, Ellie? I've just seen that you muted me. I'll keep going. Do they have the right equipment? Angle justifications, annotate the diagram and practice the reasons. Students need to practice basic differentiation. They definitely need to practice algebra with shape and space. Translations, just a reminder that when describing them, they must be given as a vector. And then equations of lines, followed by equations of lines, followed by practicing equations of lines. And if I had more space, I would put more equations of lines on. I cannot stress that too highly enough. Okay, so let's go on this final part to tiering guidance and just some resources to support you. So I spend a lot of time looking at the exam statistics every year, and I know you're under an awful lot of pressure to put all your students through for the higher tier. So if you're not aware, the last 40 marks of the foundation tier papers are in common with the first 40 marks of the higher tier papers, and we use this as part of the awarding process. If you've got students doing past papers and mocks as exams, you can actually look at the statistics of those 40 marks, and I've gathered them together for you in a second to help you decide whether this tier of entry is correct for a student. So here's all the data. I'm actually going to go to a summarized version in a second, but that's all the data if you want it. That's for the paper 2. So we've got the paper 1s and the paper 2. So this is the paper 2 FR, HR. Okay, let's have a look at the summary because it's a bit more useful. So there is something that comes out that's quite interesting. So the grade 5 students of the foundation tier scored 25 marks on the crossover questions, 25 marks, 29 marks, 25 marks, 54 marks in total. The higher tier students on those questions scored 50 marks. Okay, so Moses, evaluate is where we would ask student to, I've just seen a comment in the chat, difference between solve. Solve is to rearrange an equation to find an unknown value. Evaluate is where we would ask students to substitute a value into an expression rather than solve it. So, we would evaluate an expression by substituting a number in is probably a key point. Right, to come back to the tiering. I see this across the papers for the regional papers, the home papers, and also the UK papers. But on the crossover questions, foundation tier students usually do slightly better. And my logic is this. That is the rear end of the foundation tier papers, where students are getting a lot of practice in those and support on those in class. And the first part of the paper, they're expected to know or practice. And the same is true for the higher tier students. So for higher tier students, the first part of the paper, which is the rear of the foundation tier paper, students are expected to know, and their teachers are focusing on the rear of their paper. So we do get that the foundation tier students do slightly better on those crossover questions. But if you have, and we're not asking, would a student get a 5 on the foundation or the higher tier? Because actually part of the design of the course is that in theory, if a student was entered for the higher tier or the foundation tier, they're a grade 5 or 4 student, they should get the same grade. What we're asking here is, if you've got a grade 5 student on the foundation tier course, are they getting enough marks to be in the region of the students getting a grade 6 on the higher tier papers? So if you have a foundation tier student, and on the crossover questions, they're getting about 60 marks, they're in the grade range of the higher tier students who ultimately ended up with grade 6. So it's worthwhile considering, perhaps this is a student we should use to boost up to the higher tier, cover the extra material. Equally, if you've got a student on those crossover questions that's in the grade range of a grade 3 students on the higher tier, I'd be seriously asking the question, is this a student who would have a better chance of getting a higher grade on the foundation tier? It's a smaller amount of content, they have to revise for that, they're going to be less stressed, and we know it's stress levels that are key to student performance. And if they're focusing on more concise content on their maths, is that going to free them up for their revision for their other subjects so that they do better overall? But we shouldn't just be concentrating on their maths. And I think this is where the modular system will give us an earlier indication of that at the end of year 10 and allow us to have those better conversations with parents about what's in the best interest of their children. So just to give you an idea of the grade boundaries, okay, so on the higher tier here, a student needs effectively 62 marks. Oh, sorry, I should say a grade 6 student needs 86 marks. So if you've got a foundation tier student that's in the grade range of most crossover questions getting 60 marks, the question you need to ask yourself is, are they going to be able to pick up about another 12 marks in the remaining 60 marks in each paper to be able to get a secure 6 overall? But I think it's really interesting to look at these statistics when you're looking at your mock results and go, okay, perhaps this is more of a foundation tier student, or there's a foundation tier student that we can potentially in the remaining part of the course cover for some extra material and give them access to those higher tier grades. If you are using the main papers, I've actually got the summary statistics of those if you're using those in your mocks. So you can use either the home or the regional papers. And then in terms of some resources I've got for you, if you're teaching the modular course, we've just launched on our website a mapping document between the linear textbooks and the modular course. And the good news is that 37 out of the 50 chapters are entirely contained between Units 1 and Unit 2. 13 of the chapters need a little bit of consideration as to which questions need to be taught towards Unit 1 and Unit 2. The textbook team are working on a modular version of the textbook at the moment, but I cannot confirm a date. But we have gone to absolute detail here, question by question. That was 900 pages of textbook that needed reviewing question by question, which was a fun task. But hopefully you're going to find that useful. In terms of supporting research students, we actually have, and this was designed for the UK course, but it's actually perfectly applicable to the international GCSE course an international A-level course. So we effectively took all the skills in common between international GCSE and international A-level and UK GCSE and UK A-level, solving quadratics, indices, surds, manipulating polynomials, and we recorded videos. There's actually I think it's about 13 hours of videos of me wittering on and created worksheets. So you can use this, especially with your higher tier students, either as extra material in year 11 to give them experience to harder questions. You can use it as cross-summer work in that transition, which is what it was designed for over to year 12, or you can use it as intervention material in year 12. But we effectively have section by section. There is a video where we walk through the examples so you can see. So this is absolutely key for your higher tier students. And then there is a worksheet which contains examples for them and then questions for them to go at. The other resource that we've got coming out in the next week is a new enhanced QLA. So effectively you build in the student scores. But what I wanted to highlight to you here was we haven't done red, amber, green in relation to, if it's say a 2 marker, red is 0, green is, amber is 1, and green is 2. We've done it in relation to the exam statistics of how the students performed. So it gives you an indication. So if it's green, they're in the grade range of how students performed in this grade 7 to 9. And then we've got the 4 to 6, and then we've got a grade 3 on the higher tier. There's an equivalent one for the foundation tier. So I think it's important to give students feedback how they did in the question based on how difficult that question was. So it contains a teacher summary sheet where you can put in targets. I'm aware we get told off for printing in color. So you can actually see the arrows here, so we can see it in black and white. Gives you an indication of whether the students are on, above, or below grades. And then there's a student feedback sheet, and the students can see question by question what kind of grade range they were in. The data for today is on the Maths Emporium. So we've got folders on there. All this data came from effectively, you can download yourself on Results Plus, but it's on the Maths Emporium. And then finally, we've got some upcoming training for you. So we've got understanding assessment and improving outcomes in international A-level. Getting ready to teach the international GCSE Maths modular, and getting ready to teach the international advanced A-level. I do hope that session has been useful. Please do give us your feedback on the feedback form, and I would love to know if on every slide where I was showing a question, whether there is something that you can take away and use in your classroom to improve your practice and improve the outcomes for students. I hope that's been useful, everybody. Do follow me on LinkedIn. It's where we make a lot of the announcements. There is effectively the QR code to follow me on LinkedIn. And I hope you found that useful. And we are almost exactly at time. I have a couple of minutes left. I will turn my camera off, but I will keep an eye on the chat. And if you've got any questions, please do put your comments into the chat or questions into the chat. And otherwise, hope you have a good day, people. I'll speak to you again. Bye now.